Exactly. It doesn't matter, it's the same name, here or here, it's exactly the same compound, but just so. And, okay. If we wanted to say boiling point, which of this will have a higher boiling point? Boiling point, not melting. I'm asking boiling point. Which of these two will have higher intermolecular, higher surface area, higher boiling point? So the boiling point will be like that. This will have a higher boiling point than that one. But melting point, look at this data. Which number is bigger? Minus 160 or minus 17?
Minus 17.
Okay, so will be for melting, MP, abbreviation for melting point. For melting point will be opposite. Because you didn't, when we measure the melting point, and you will do this in a lab, we take the substance and we peg in the capillary tube to measure. We have to peg them. So if pegged well, so that's why, remember, it's opposite if you have symmetry, if the functional group are the same, of course. If functional group not the same, that's a different story. But if functional group are the same, then more symmetrical, higher melting point. And what can be opposite than boiling point. Most, so has a symmetry. So how it will be if I add here this one? 1, 2, 3, 4, 5. Pentane. Where the pentane will go if for boiling point? If I wanted to rank them. Melting point. If I wanted to, so this will be the lowest because this has some plane of symmetry, but it's not as tight as this one. Do you see this? So this will be this solubility. So if you have solute and solvent, you talk this in general chemistry, then interaction between solute and solvent give the energy to break those interaction between solutes. So you talk this in general chemistry. Now, this and solvent, and the top one is example of organic solvents. Organic solvents are non-polar. The top one is non-polar or slightly polar. Very common organic solvent is ethane. Slightly polar, that's interaction in between. So this, what type of compound it is? Ketone, because it has 2 carbons on each side of carbonyl. Is ketone, can you dissolve ketone in organic solvent? Yes, all organic compounds are dissolved in organic solvents. All organic compounds you can dissolve in organic solvents. But in water?
Yes.
This one, yes, but not all. So this one, yes, because you have 1 oxygen and 3 carbons. If I will have 10 carbons and 1 oxygen, no. So what, if you can, what make some compounds soluble in water? Polarity and hydrogen bonding. If you can do hydrogen bonding with water, if a compound can do hydrogen bonding with water. So hydrogen bonding. This, there are three compounds listed. Which of these can do the question? Let's look at this question. The first question is asking because similar bond to itself. So it means you have only what is the first one? What type of compound is the first one? Is type of compound. Is this alcohol? No way. What type of compound? Oxygen is attached to carbon, and what kind of bond have to be between oxygen and carbon for carbon to have four bonds? So this must be receive, and this first one I will show. So the first one is ketone. I will just show condensed structure, but less condensed than the other one. So the first one is ketone. The second one is amine. Yes, it's a nitrogen, but there is no carbon. So this will be like that. And the last one is also amine. This is tertiary amine. Can this do hydrogen bonding with another like that? If you have only this in a test, if they can do hydrogen bonding with itself, can they do what you need to have to do hydrogen bonding? Or hydrogen attached to oxygen or nitrogen. Do you have a hydrogen attached to oxygen here? No. So the answer should be no, you cannot do hydrogen bonding with itself. Because oxygen is only hydrogen acceptor, but not donor. Like you don't have a hydrogen donor here, but because all hydrogen are attached to carbon. So here, no, it cannot do hydrogen bonding with itself. Can this do hydrogen bonding with itself? No, because all the hydrogen are attached to carbon. You don't have a hydrogen donor for hydrogen bonding. And this one, yes, because hydrogen is attached to nitrogen. So this hydrogen can be donor, and another molecule, nitrogen, can be acceptor, and they can do hydrogen bonding. Okay, next question. Which can hydrogen bond with water? Can this do hydrogen bonding with water? Yes, because water will be hydrogen bond donor, and this oxygen can accept. Can this hydrogen bonding? Yes, and this, yes, all of them can do. So all of them can do hydrogen bonding with water. Okay, solubility of this alcohol is this soluble in water? Yes, you have two carbons for one to do for one oxygen that can do hydrogen bonding with water. What about this alcohol? Cholesterol? No. So you learn in biology too. This is hydrophilic, and this whole part is hydrophobic part. So you have too many carbons. So overall, this is not soluble in water. Alkane are insoluble. Alcohol, if you have 5 or less carbons on each oxygen that can do hydrogen bonding with water. And if you have like more than 5, then you cannot. But all of them, except ionic, all organic compounds are soluble in organic solvents. Group work. Here are my notes. If you want to check your notes with mine, and I will give you quickly. Check if you have a